Welcome to Strength of Material lectures by Civil Thinking, and in this class we are going to solve another problem using equation of torsion of shafts. Okay, now before I move on, I suggest you to please watch the video lectures on torsion of shafts one by one as in the playlist so that you understand better. The playlist link is in the description, or also you can click on the pop-up on your screen. Now coming to the today's class, now we have this problem here, a solid shaft. Okay, we have a solid shaft. Okay, it is solid, diameter is provided. Okay, it is 150 mm, right? Is used to transmit torque. Okay, find the maximum torque. Okay, we have to find the maximum torque. T is maximum torque, right? And if the maximum shear stress induced to the shaft is 45 Newton per mm square. Okay, so we have tau max is what? 45 Newton per mm square. Okay, so how do we solve this? Now again we are going to use the what? Equation of torsion. Now what is the equation of torsion? This is the equation of torsion. Tau max divided by R is equal to T by J is equal to C theta by L. Okay, so this is the equation of torsion of shafts. Okay, now I have already made a video lecture on this. Okay, I will provide the link in the description to check out where this came from. Okay, so let us put the values here. Now we have here tau max. Okay, it is 45 Newton per mm square. Okay, now radius is half of diameter. Now diameter is 150 mm. It means what is the radius? Radius is half of 150 is 75 mm, right? So we have radius is 75 mm, right? Torque we have to find, and J is what? J is the polar moment of inertia of solid shaft, and the polar moment of inertia of a solid shaft is given by pi r4 divided by 2. Okay, again I will put the link of this equation in the description so that you can see. Okay, now it is equal to pi times 75 mm power 4 divided by 2. Okay, now as usual we have to find T from here, right? So we have to find T from this equation. Okay, now in one way I can rearrange this equation. Okay, then find the value of T, but that will take a lot of time, so I will just use the scientific calculator and I will put the values there. Okay, so let me use the calculator. We have tau max is 45 divided by R is 75 equaled. Now T we have to find, so I will keep it like X divided by J. J is what? Pi times 75 power 4 divided by 2. Okay, now from here what do I get? I got the value of torque to be 29820,586.5. now what is going to be the units? Now the length is in mm and the force is Newton per mm square, so we are going to get it like Newton mm. Okay, now we have this answer in Newton meter, so I have to convert it into Newton meter. Okay, so millimeter is less than meter, so if I have to convert it to meter, okay, so basically we are increasing it. Okay, so I have to multiply by 10 to the power minus 3, right? So it is going to be 3 decimals backwards, right? So it is going to be somewhere here. Okay, so it is 29820 point, now 58 I can round it to 6 Newton meter. Okay, so this is our answer, 29820.6. okay, so we got a correct answer. Okay, and that's it. If you have any doubt, you can comment, and see you in the next class. Thank you.